Hello guys, good evening and welcome to the SAT class. Yes, this boy is Satsfred and welcome you all to the class. This is our first session and then our first rule video. This is our first video and subsequent ones we'll be adding more videos to it. Alright, so today we are doing the SAT math. So today we are solving quadratic equations. So quadratic equations usually appear a lot in the SAT and they come a lot. They occur most times. Almost every SAT paper you write will be a quadratic equation. So you have to know how to manipulate them and then you have to know how to solve them too, right? Alright, so they say we should know our vertex form, how to solve the quadratic equation in a vertex form. So it's very important. And then yes, how to manipulate them also. You have to know how to manipulate quadratic equations. Okay, so let us move on and then let's see if we can do something. Okay, so let's go to the basis of quadratic equation. So we always know the quadratic equation is written in the form. We have it's in the form ax squared plus bx plus c. Alright, so the vertex is the general form ax squared plus bx. So you can call it the general form. So this is the general form. So let's name it J. Alright, so if you want to find the vertex is x and y. So if you want to find the vertex, so you want to find the x value of the vertex is x is equal to minus b over 2a, right? Alright, so let's say you have x squared minus 2x plus 1. So our vertex will be x, the x coordinate of our vertex will be x is equal to minus 2 all over 2 and then a is what? 1, right? So our vertex is x coordinate is minus 1. Okay, so we want to find the y coordinate of the vertex. Y coordinate, we just put it back into our equation. Right, so let's put it back into our equation. So you can say you put negative 1 into what? X. So we have negative 1. So okay, so it's in the form y is equal to y is equal to a squared plus. So y is equal to negative 1 squared plus so it's minus 2, so you have minus 2 and then what? Negative 1 plus 1. Alright, and so we get 0. Therefore the vertex, our vertex is what? 1 and what? 0. Alright, now in quadratic equation we also have quadratic graphs, right? So I believe we've already been taught in SHS, so we won't go through, but we just have to know some basics for the quadratic graph. We won't teach you a lot, so let me just clean this and then let's see the graphs. So for our graph, so we always have y is equal to ax squared plus bx plus c. You want to know the limit, right? So for example, if this a, the first coordinate, the coefficient of the x is positive, then our graph opens upwards. Now if this a, the coefficient is negative, then our graph will, if this coefficient a is negative, then our graph will open downwards. Now if a is very large, so if a is very large, very large, then our graph will be smaller. You get it? It's very small. And then if a is very small, if this a is very small, this is very small, then our graph will be very wide. It will just open. Alright, so let's move on. We are still on the vertex. So for the vertex form, if you want to find it, it's in the form. Let's move on to vertex. Right. So let's move on to vertex. So vertex. So you have to manipulate a quadratic equation into a vertex form, right? So this is the vertex form. Y is equal to a x minus x squared plus k. Alright, so y is equal to a x minus a squared plus k. Alright, so where the vertex is h, where h and k are our vertex. So if you have y is equal to minus 2 x plus 1 squared minus 4, then our vertex will be negative 1 and negative 4, because h is always negative. Because here is positive, it means it is negative, right? So we want to convert from a standard form to a vertex form. We want to convert from a standard form to a vertex form. That is, you have two ways of doing it. You can use completion of two squares, but you can use completion of squares, which is a very long method, or you can use the easier method to solve it. Alright, so let's see the easier one. Which we always use. So let's look at this question. So let me choose it. So we have y is equal to x squared minus 2x plus 1. Alright, so when you want to solve it, this is the standard form. You want to send it to vertex form. So for such a case, we will write our y is equal to x squared minus 2x plus 1, and then we shift the 1 to the other side. So you have y is equal to x squared. We have x squared minus 2x, and then we break this 2 into 2, we split it into 2, so therefore we get, then we square it. When we split it into 2, then we square it in brackets, so x minus 1 all squared, right? Now x minus 1 all squared is the same as x squared minus 2x plus 1, right? So to give you the same thing, so instead of no worrying to manipulate, we just, our 1 is already here, right? Plus 1 here, so we just subtract minus 1 from it, because if here is already plus 1 and this one also be plus 1, in order to balance, we have to subtract minus 1 from it. So we get here, we have to get 0, right? So our vertex is what? 1 and alright. So we are continuing. So we have x minus 1 plus all squared plus 0. So our vertex is what? 1 and what? 0. So this is a simple one. You just have to split this one, and then you split this to the, you move the other side, the first equation, the other number here, or number here. Let me highlight it. So you move the number here out, move this number, then you split this one. When you split this one, then you square bracket it, and you subtract the same number from it, then you see what to do. So let's see a sample question, right? So let's go to the related equation. And then the other way of solving a quadratic equation, I think I missed that one. Alright, so let's say you're given a question like, you have 2x squared. So that's about manipulating quadratic equations. So 2x squared plus 7x minus 15. Alright, so for that you can look for a number that when you multiply to a negative 15, you get negative 30, right? So you look for a number that when you add, you get positive 7. When you multiply, you get negative 30. So we're trying to disengage it. So we have 2x squared. So the number is turning negative 30. So 10x minus, so x minus what? 15 is equal to x 0. So we have this and this. You can just factorize, right? So you have 2x will do what? X plus 5. So minus 3. X plus 5. Right, so we have 2x minus 3. We have what? X plus 5. So we are looking for the x and y. So we manipulated this into this equation, right? Right, so let's move to our normal ACT questions, and then let's see some of the type of questions that you may get from the manipulating quadratic expressions and then parabola. Okay, alright. So let's move. Alright, so quadratic equations. So you have our first question. This is ACT practice test 1, question 30, calculator. Alright, so you want to be very fast as possible in solving, but have to go slow. Alright, so they said which of the following is an equivalent form of the equation of the graph shown in the xy plane above, from which the coordinate of vertex A can be identified as constant in the equation. Alright, so you know that the question they are looking for. So let me use the reference. Right, so you know that we are looking for some kind of vertex. So vertex A, so the vertex is A, so we know that vertex form. Alright, so our vertex will be H and X. Okay, so when you draw a graph, so if you draw a graph like this part is the vertex, right? So this is the H and X. Okay, so they have given us the equation, we get it, and then they want us to manipulate it. Which of the following can be identified as constant? Alright, so in any way you can see which one is the vertex, right, as constant. So here we have x is minus 3, so we can write what? X plus 3, and then here too you have x is 5, so you have x minus what? 5. In such a case that x plus 3 and x minus 5 is equal to 0 when you solve manipulate the quadratic equation. So x equal to minus 3 x is equal to what? 5. So you have x plus the limit x minus 5. When you solve it, you get the same equation. So you have the same thing, x plus the x minus what? 5. Now let's see if we change this one to vertex form. Let's see. So you have x squared minus 2x minus 15. So we split this one into 2. So you have x minus what? 1 squared. Alright, so x minus 1 squared. Alright, so x minus 1 squared is the same as x squared minus 2x x squared minus 2x plus 1. Right, so this is plus 1. We already have minus 15, so minus 15. So in order to remove this plus 1, you have to subtract 1 from this minus 15 to minus 1. So it will become minus 16. So it will x minus 1 squared minus what? 16. We also have this answer there, right? But which of the, so we are looking for equivalent form of the equation of the graph, from which of the coordinates of the vertex, right, can be identified, right? Which is the coordinate of the vertex? This is the coordinate of the vertex. So you see, you get it. So you have what? When you take it here, you see that the coordinate of the vertex are what? This and this. So it is what? We already told you that a vertex is formed is what? Y is equal to a x minus what? H squared plus what? K. So the coordinate here is 1. So it means here has to be this one is 1. So it means here has to be what? Negative what? 1. And then minus 16. Right, so plus k, but here is minus, so it's what? Minus what? 16. So our row answer is what? Our row answer has to be what? Our row answer has to be D. You get it? So A is wrong. So we are looking for the coordinate of the vertex, which one can be identified, right? So it has to be this form, the vertex form, the row vertex, and the rest are not correct. We just use the tricks. This one is an equivalence form, but it's not the vertex form, right? So let me go over again. And then, let's see if you can understand it clearly. So let me go over again. So they said which of the following is an equivalent form of the equation of the graph shown in the xy plane, from which the coordinates of the vertex A can be identified. So you are looking for a vertex, right? A vertex form. So for a vertex, this is our vertex, right? So this is our vertex. You are looking for the coordinates of the vertex. So you know if you just drop this and that, you have what? So coordinates of vertex are what? So x is, I think x is 1, and then y is, you can place it to minus 16. Alright, so you already know our answer, but let's see. Our answer is inside, so we can, but let's check. Sometimes if it's not giving you the graph, if you can manipulate the equation, the vertex form, and see if you can solve it. Okay, so our vertex form is always y is equal to a x minus h squared plus k. Okay, so let's see. So as I was saying, our vertex as I was saying, our vertex function is always in the form y is equal to a x minus h squared plus k. Alright, so let's take our equation. So our equation is already given it to us. So we have, okay, let me notice something here. So we have y is equal to x squared minus 2x minus 15. So when you finish, you can ask questions. Alright, so we split this one into 2. So we have x minus 1, right? Then you square it all squared, but then we need this negative 15 here. Right. So when you expand this one, you get x squared minus 2x minus 1. So x squared minus 2x minus 1. Right. But I already have negative 15. Okay, so it will be plus 1, right? X squared minus 2x plus 1. But I want to move this plus 1 out of it. You get it? It's plus 1. So we have to subtract minus 1 from it. So then we have to bring out minus 15. You get it? Right. Sorry. I think I made a mistake. Right. So when you expand this, you get this is the same as x squared minus 2x plus what 1, right? So but if we add a negative 15 to it, it means if you add a negative 15, it means we are lacking here, right? So let's expand it, right? So x, I just want to make it to x squared minus 2x, right? So plus 1, this is the same as this, right? Alright, so you want to get this, we are looking for this one, we close this one, right? So we have to get rid of this what 1, because it was this x squared minus 2x that we are looking for, right? So we just have to subtract this minus 1 from here, we get it. So therefore we get we have to get what x squared. So we have to get x minus 1 all squared minus what 16. And so still answer, you can just switch and answer is 15. Right, so we get other questions and then we solve. So let's move on to the next question. Right, so this is an ACT question. This is ACT practice test 2 calculator question 7. Alright, so calculator question 7. Let's see. So this is a parabola. So the equation above represents the parabola in the xy plane. Which of the following equivalent forms of the equation displays the x-intercept of the parabola as constant or coefficients? So the other one was vertex, and the other one is, this one is what, constant. So we are looking for constant. So it's imagine the form. So if you see constant, so we've already done this in pictures. It's imagine the form x, they're looking for the x-intercept. So x is equal to a, or x is equal to what, b. Right, so this one you have to manipulate this one, right? So looking for the x-intercept, right? So we have x squared minus 6x. Let's see, this you don't see vertex form, but the vertex form, if you go and change it to vertex form, you get it from plus 8, right? So we will look for a number. We look 1 times 8 is 8. So we look for a number that when you multiply 1 by 8, and then when you add When you multiply, you get 8. Or when you add, you get what? Negative 6. Alright, so let's see how you can do it. So 8. So let's see the factors of 8. Alright, so you have 2 and 4. And 2. When you 4 minus 2 is what? When you add, right? Negative 2, negative 4 will give us what? Negative 6. And negative 2 times 4 is what? Positive 8. So you can write x squared minus 2x. Alright, so I'm making this. So that's x squared minus 2x minus 4x plus 8 is equal to 0. Right, so this one tell me if you this equation. Okay, so this there is nothing to let us put this one straight there. That's it. So x minus x 2 minus 4 x minus 2, right? So we have x minus 2 x minus 4. So you've gotten the x intercept. So x is either 2 or x is 4. So this is our answer. Our answer is x. So it's simple. You've already done it before. You just check with the question. So let's see this another question. Alright, so this one is more or less a little bit difficult, but it's simple. So in the equation above, a is a positive constant and the graph of the xy plane is a parabola. So we've seen another parabola here. Which of the following is an equivalent form? So we are looking for an equivalent form of the equation, right? Okay, so let's just look at the possible answers. X plus a, x minus a is difference of 2 squares here. X squared minus x a squared, right? So it's wrong, right? Alright, so x plus a, x minus a is also difference of 2 squared. So you have x squared minus what? It's a all squared. So this one, I think it's a squared, this one cancel this. So we have, so that will give us, this one will give us what? X squared minus a. I'm just testing myself, so it's writing it a little bit. X squared, so we've already gotten it, x squared minus a. And so we don't need to waste our time on the others. This one we'll expand it to get this, and this one too is so lousy. So this one they just wanted me to think a little bit and then apply some mathematics. Right, so let's see the question. 4x squared minus 9. In the equation about p and t are constants, which of the following could be the value of p? Alright, so we have px plus t, px minus t. They also want us to it's also a quadratic, but it's a difference of 2 squares, right? So this one is this is square, this is square. So 2 squared is what? 4. So you can just make this 2x 2x or let me connect. Alright, so it's just simple. Alright, so 2x all squared minus 2x all squared, right? And so this difference of 2 squares, right? So 2x plus 3. Then we have 2x minus 3, right? So it corresponds to what? Px plus c, px minus t. So it means therefore p is what? So our answer is what? Right, so our answer is A as we choose, right? So let's move on to the next question. So this SAT practice test 6, new calculator question 11. So we are following the parabolas, and then let's see if we can do something about it. So we go to another vertex form. So you see how they manipulate the questions. Vertex, quadratic. So it's the same thing. So the vertex of the parabola in the xy plane above is 0c, right? So they're given as a vertex. Which of the following is true about the parabola with the equation y is equal to negative a x minus b all squared plus c, right? So they said a, the vertex is b, c, and the graph opens upward. B, the vertex is bc, and the graph opens downward. C, the vertex is negative bc, and the graph opens upward. And D, the vertex is negative bc, and the graph opens downward, right? So let's see. Let's see if you can solve it. So I already told you that the smaller, right? I already told you that the smaller the a value, right? So the smaller the a value, then if the a is negative, or if a is smaller, if a is negative, right? So if I told you that if a is negative, then our graph will open it downwards, right? If a is negative, then our graph will open downwards, right? So opens downward is open, so automatically opens upward is cancelled, opens upward is what's cancelled, right? So a is negative, right? So this is not the same parabola, but it's giving us this. You see, they've tricked us with this parabola, but the real equation they are saying completely set. This which of the following is true about the parabola with the equation this. So a opening what's downwards, right? So and then the vertex, so we have vertex is what? A x minus h squared plus k, where h and k are the vertex. So let's see this is the same thing. So we look at this one, so negative a x minus b squared plus c. So our vertex is what? B and c. Right, so it means our graph opens downward and our vertex is B and C. So here they said the vertex is negative B and C, so this one is cancelled. So our real answer is this B. So if you are simple, so if you know the concept, it will be very easy for you to solve vertex one. Alright. So let me go over again. I said let me go over again. So I said what? If a is negative, the graph opens downwards, right? And then this is a general form of the parabola y is equal to a x minus a squared plus b, where h and k are what? Vertex, right? So this is equivalent to this. Then here to our vertex is B and C. So when you look at the question, graph opens downward and our vertex is B and C. So we choose the B for the answer. So you can go and check the answers if you have any question, but I believe my answer is correct. And so you have SAT practice test 7, new calculator question 7. This is an example of parabola form. So they're giving us this one. So which of the following is equivalent to the expression above? So you can see that's also, this one is also a question where you're supposed to change it to the vertex form. So you see they didn't even tell you it's a vertex form, but they just ask you which of the following is equivalent to the expression above. So you have to know how to solve it, right? So I believe I've taught you. So you can pause the video and then you pause the video, then you solve it when you finish, and then you can check your answer. So pause it for like 30 seconds, and you have to use the 30 seconds to solve it. Alright, so let me solve. I use the purple pen. So we have x squared plus 6x plus 4. Alright, so for the vertex form, we split this, so we have x plus third all squared, right? Now this x plus 3 all squared will give us x squared plus 6x plus 9, right? So it's just plus 9. So if you want to get the same thing, you just have to remove negative 9 from the equation, right? If you want to get this x squared plus 6x, you want to get this to the equivalent formula, because we just have to negative 9 from the equation, right? So we just have to remove 9 from the equation. Remove 9 and add it. 4 to it again, right? So we have x plus 3x squared minus what? 5. So definitely the answer is what? D. So let me do it again. So we split this x squared plus 6x plus 3, split this into 2, so we have x plus 3 squared. And then when you expand this x plus 3 squared, you get x squared plus 6x plus 9. But what you want is this, because you put our 4 somewhere, so you just have to move the 9 from it, and you bring that 4 back, so you get this, right? So you just have to splitting, removing, and then adding, so you get this, right? Okay, so I think we end here. This on the parabolas. With the parabolas, let's take notes. Let's see if you have another question. Right. So if you have any question, so let's take note of the parabola. So you have to know what people like the purple form. So you have to know the vertex form, for the vertex form, and then the graphs, whether it opens upward or downward or it's enlarged. Just have to know the concept, right? And then you also have to know how to calculate it to x function. Let's say x minus a, x minus b. So basically these are the things that are needed in the SAT that you need to know. When you're positive and negative, you have to know them, right? So you have to know that the general form for the vector form is what? Y is equal to a. You just have to know this one. A x minus h squared plus x. So you have to know this one too, right? And then basically that's it. So some of them. So basically that's that. So let's see. So we have to know the graph too. Alright, so thank you for watching the video, and then next time when we come, we will be doing so if you have any questions, you can ask after the video. Next time when we come, we'll be doing linear function with problems. So linear function with problems. So we have to know the slope versus y-intercept. So the equation is always in the form y is equal to what? Mx plus c. Y is giving a word problem, right? So you have to know this form. You have to know the slope, right? At a conceptual level. Slope versus at a conceptual level. So thank you for watching the video, and then have a nice day. So I'm recording this video on the election night. I think the day before election is coming up, so I don't know it's going to impact. Thank you very much, and I'm very sure. Thank you so much for having patience, and let's see how our first video will go, and hopefully we can upload more on YouTube so that everybody can get access to the class. Alright, so kudos, and thank you very much. Bye. Ciao. Bye bye.